Good afternoon once again. Today we will discuss once again Gauss Law. As you have commented to do once again the Gauss Law, so I have come with the Gauss Law once again. This is a review video, and the dated is 11th May 2020. So now we will start the Gauss Law. And to start is the Gauss Law is very important. We have some applications of Gauss Law also. And students, I would like to request you to understand the Gauss Law. You have to see the previous videos, and you have to well equipped with the small definitions like a flux. Okay, so you have to understand what is the flux, what is the field lines, how the field lines is acting. So all this, if you know, means you can understand Gauss Law very easily. Today I am not going to put any words which will be very difficult to understand you. I will try to use a very small and a very wide ranges of the words so that you can understand the Gauss Law. I will focus basically in mathematical analysis, so that you can understand very fast the Gauss Law. Before going to Gauss Law, I will just tell you the flux. Simply, this is the review of the flux. Means flux we are finding means flux is denoted by phi. It is a scalar quantity. You know that, and the flux can be measured. Flux can be measured. This is simply the scalar product of field and area. Field and area, or you can say EA cos theta. This is the scalar product of field and area. Area means the surface which is enclosing the charge. Suppose this is the charge enclosed by this area. Area is S. Then field will be here. Suppose E. Then you can find the flux. Means flux will be E dot S. And then later on this cos theta. This is the theta means this is the direction between area. This is the direction between field and area. Field and area. Whatever the direction of field and area, the value of theta will be determined whether it is 0 degree or 90 degree. If 90 degree means flux will be 0. 0 degree means flux will be maximum. So once you know the flux, means you can calculate very easily the electric field. And Gauss Law is have very well advantages to find the electric field due to the charge. So let's start Gauss Law. Gauss Law simply is stating for a charge enclosed by any surface. Suppose here this is the charge, or you can say point charge, is enclosed by this spherical surface. Okay, this is spherical surface. And this spherical surface, this is suppose positive charge, so definitely the field lines will be coming here. I am taking just only this elementary area of this surface, this elementary area, and the elementary area is ds, suppose ds, and the area, full area means total area is S. The direction of this area and the direction of field will be along the same direction. Means you have understood here the value of theta is 0 degree. So maximum flux can be taken. So what Gauss was suggesting, if a charge is enclosed by any surface, be careful, here charge should be enclosed, charge should be surrounded by the area. Then the flux will be equals to the 1 by epsilon naught times total charge placed at that point. Epsilon naught means, once again, here the role of medium. So what medium you are choosing, that medium's permittivity we have to write. Suppose this charge is surrounded by this surface, having the surface area is S, and it is kept in the air medium. Here suppose air medium. Then what is the permittivity of the air medium? We are choosing epsilon naught. So once again I am telling, the total flux due to this surface area enclosed by or enclosing the charge plus q will be equals to 1 by epsilon naught times the total charge placed at the point O. Then how to write it? So very simply it is. So you can write here the total flux means phi tell you, this is the total flux. But whenever we are choosing a very elementary area, small area, then what will happen? No. So here nothing to worry. If here the elementary area is chosen, or suppose this area is divided into number of parts so that ds tends to 0, ds tends to 0, it is not 0 but it tends to 0, then what will happen? Then it's easy, you may find the flux through this area only. So if we are finding the flux through this area only, so a small flux will be there, this will be the small flux, a small flux, so a small flux d phi can be written as E dot ds, E dot ds, and suppose they are in our unit vector n. Then what will be the total flux with this? Simply you have to add the flux due to this small area, Suppose there is a number of area means ds1, ds2, ds3, ds4, number of area, then all flux you have to add it because this flux is a scalar quantity. And instead of adding, you can take one simple integration. This integration will be the surface integral. Why surface integral? Because surface is chosen here, so that this will be the surface integral, and if you use the surface integral here, E dot ds in factor n, this also will be the total flux. This also will be the total flux. Then again, Gauss law can be related with this equation. And this equation, if you relate this is the total flux, then you can write it. So E dot ds in vector n is q by epsilon. Either you write this or you write this. Both are the Gauss law. Both are the Gauss law. Now the question arises how to prove it. How to prove it? Or you can once again you can define it also, the surface integral of scalar product of electric field and the elementary area along the unit direction of unit vector is equals to the total charge placed at the point O divided by permittivity of the medium. So this is your Gauss law, or this is your Gauss law. Now the thing is that how to prove it. So very easily you can prove it with this diagram only. Suppose I am choosing this spherical surface. This is a spherical surface is chosen, so that it will be surface area is 4 pi r square. You know that it's very simple. So if I write here total area, this is the proof. So you can write a very simple language. Let us consider O is the center of this surface. O is the center of this surface, which is enclosing this charge plus q, so that this surface is known as Gaussian surface. This surface is known as Gaussian surface. Once again I am telling, if you go to the application of the Gauss law, you will have the one very important point to be followed, that is the Gaussian surface. The charge must be surrounding, charge must be surrounded by the surface, that is called Gaussian surface. And Gaussian surface is not a real surface. It will be the imaginary surface. It is the imaginary surface we are imagining. Or if there is a real surface which is enclosing the charge, even the Gauss law is valid. So if there is no, if the charge is not surrounded by any real area, we can consider the imaginary area, so that the charge should be surrounded, and then we can use the Gauss law and we can find the electric field. So here this surface is said to be the Gaussian surface, since here we have chosen the real surface. So real surface is S, and its surface area is 4 pi r square, where r is the radius of this Gaussian surface, and O is the center where the positive q charge is placed. E is the electric field, ds is the elementary area. Either we can use elementary area ds or direct the area as you can be used. So for this, if we need to write the electric field at any point on the surface of this area, what will be the value? What will be the value? Any point, but it should be on the surface. So it is very easy. Means electric field E will be 1 by 4 pi epsilon naught. The charge is q, and by r square. Why r square? Because distance is all everywhere. This is the radius, so r square. And you can write the unit vector r direction. Then find the value of flux. So flux. Suppose first a small flux means a small area means E dot ds. Suppose they have the value of theta is 0 degree, so maximum flux will occur E ds. So total flux, if we find total flux, I have told you the flux due to this small region we can calculate, and we can 4 pi epsilon naught q by r square. Then ds, here the ds is the variable which is to be added, no, small ds then, and n is RMO because both they have the values means theta is 0, so maximum flux is there, so no need to write 1 by 4 pi epsilon naught r square cube. Now here I am writing the integration of ds will be the total area, and total area is 4 pi r square. So use here 4 pi r square. So 4 pi r square, 4 pi r square will cancel. Only q pi epsilon naught is remaining. So phi is q by epsilon naught. Hence we can say that the Gauss law is proved. Now there are the few applications of the Gauss law. Means that will be another topic. Once you understand the Gauss law, it is very easy to do the applications of the Gauss law. Here, the very importance, there is many importance of the Gauss law. The importance of the Gauss law means you can find immediately the electric field due to the charge distributed over like a infinite long conductor or infinite plane sheet, or you can try like you can find the electric field due to the charge spreaded continuously spreaded over like a spherical rings or any shapes, because Gaussian surface, once you are able to consider, then it is very easy to apply the Gauss law, and Gauss law will be very much helpful to find the electric field. Thank you students once again, and please see every video full from beginning to last. In between if you see means you will not understand, and all the assignments which is provided to you, you please do it, and you can submit. If you can submit means by online, so it's very it will be useful. Otherwise you can do it at your home. Thank you. Have a nice day. Bye bye.